Hi everybody, my name is, as is clearly visible on this black and white slide, is Jānis. And I'm gonna talk about how we can combine some daggers and a little bit of coffee. So the Vanity slide goes a little bit like this. I've been coding for about 10 years, and it began in a bank as an intern, carrying projectors up and down the building. It was fun. Got in really good shape. So now I'm at FullContact, and the way I've come to Android is through starting with HTML, then PHP, then some JavaScript. Did a little bit of DevOps when DevOps was still the thing, or was still the cool thing everybody wanted to do. Did some Android, and now I'm trying my hand at managing and also writing a little bit of Android code on the side. And this is my first tech talk ever, so please be hard on me, spare nothing. I really like the black and white color scheme because I hate when people make their slides too colorful or something. Okay, so 5 seconds about FullContact. We are helping people all around the world be awesome, to connect with their contacts, keep their lives up to date. We currently have web, Android, and iOS apps, all of them native, some of them more functionally programmed than others. We have a public API for contact information enrichment. Please go to FullContact.com and take a look at it. Even if you don't think you need it, I think you need it. We currently have offices in Riga, Denver, and Kochi, India, and we have a really kick-ass development team, and I'm hoping to bring more people over here to like these meetups and talk about the cool stuff that we are doing. So keep an eye out for the vacancies that we may have, also FullContact.com. So who knows what dependency injection is? Anyone, raise of hands, please. Okay, so a fair number of people do. So dependency is based on the dependency inversion principle and saying what you need instead of saying how you can get what you need. So you ask something to give you some dependency, and you know, it gives it to you. And it's a really good and easy way to keep your concerns separated. A really good way to start working with dependency injection on Android is Dagger 2. If I use the name Dagger somewhere else in the talk and don't use the 2, it's meant to represent Dagger 2 still. And the main selling point for Dagger 2 is that there is no reflection. Who can tell me why that is good? Anyone? Yes?
It's faster.
It's faster. Okay. That's exactly the point. So on Android, we are extremely resource constrained. So we really got to take care of how much time we take doing each operation. And if we need to construct a bunch of new objects and we need to do reflection for each one of them to find out what their dependencies are, that takes a lot of time. And we don't have a lot of time. People usually, what was that, something about 160 milliseconds? So if something takes more than 160 milliseconds to happen, or a new screen takes longer than that to show up, people notice and feel that it's slow. So another thing is that it has a really pleasant interface. I remember back in the day working with enterprise Java, there was this, what was it called, GUIs or something, and their dependency injection was done in XML files, and you had to guess like which names you had to put where, and a bunch of attributes and whatnot. So that was a little bit painful. Dagger 2 works on Java standards-based @inject annotations, and it's currently developed and maintained by Google. It started out in the place where most of the good Android libraries come out from. Can anybody name the place, the company? Yes, Square. So Square guys started it. Google was like, oh my God, this is so good, we need this. And yeah, they took over. So let's move on to the next part. So How many of you are actually doing Android development? Okay, so we have, let's say, about half of the people here. Okay, so from half of the people here, how many of you have tests for your application? Okay, 3.5, no, okay. Something like 6 hands, okay. How many of you have unit tests? Okay, 1, 2, 3, still good. The number's dropping. How many of you have UI tests? UI tests, 1, 2, okay. So the number dropped fairly quickly there. Okay, so UI tests are tests that are physically run on your device, whichever device that is. Either it is a virtual machine, or is it a physical device, or it's I don't know, some simulator, or you have the fancy new spangling setup running in Docker or something. UI tests in the context of Android are they are run on the device to check the UI if the UI is working correctly. And as always, you should be using them sparingly. Most of your tests should be unit tests, with checking just, some smaller things in UI tests. That's in the ideal case. What we see more in day-to-day development is that UI tests seem to be a bit more approachable if you have a larger code base already there. And again, any good tests, regardless on which level, are better than no tests. So on Android, most current apps, I'd like to think that most current apps use Espresso. And Espresso is a UI testing framework that is designed and made specifically for Android by Google. It's had a bit of a bumpy past, where the first incarnations of Espresso weren't really pleasant to work with. But now it's actually usable and it's stable, and there are a bunch of things to look at here. So it has a nice API, and having a nice API with which you can write meaningful tests which explain themselves and run fast is an important thing. I'd argue that even more important is the no syncing with the lifecycle. And I can't stress this enough, how nice it is to not have to worry about if your assertion is going to run before the activity has finished loading. So as I mentioned before, this runs on any device anywhere, and this is going to come now. Yeah, maybe there's a slide afterwards, but so if you have 10 phones in your office, you can hook all 10 of them up to a single computer, push a button, start running your tests. They're going to run on all devices, probably concurrently. You don't have to recompile the source code for them separately, and it runs your actual code. So another really good thing is Espresso Test Recorder, and again, no syncing with the lifecycle. So let's go through these. So nice API means Espresso uses Hamcrest. Has anybody heard of Hamcrest? Yes, we have somebody. Okay, maybe two. Hamcrest is nothing new. It's an assertion library originally made for Java, but it's now been ported to C, PHP, JavaScript, you name it. And it asks that you start thinking more like the user while you're actually writing your tests. So, do I have a laser pointer? Yes, I do. So if you're writing a test, so you are thinking like a user. Okay, so I really want to find a view which has some specific property. So if I'm opening the app, I'm looking for a field that looks like it is a date. And if I find that field, I want to check if the content matches this. So thinking like a user. Can I find this? If I find it, do I see what I'm looking for? In the bad old times, who has worked with Selenium? Okay, how many of you have written things like wait for element? Yes, wait for page to load. Wait until something happens. Wait until JavaScript executes. I remember way back working on this and in PHP, and it was just, thinking like, okay, so what needs to happen and when can I expect this to happen and how much time do I have to wait for? It's gone. So in Espresso, you just write, I want to click on this date. I find the date, I click on it, and you just write the next assertion. And Espresso has hooked into your activity lifecycle, and it knows when the next activity starts loading, and it knows when it's finished loading, and it knows when something else starts to happen. So you don't have to think about it usually, as with all things. So, well, then on the question, well, how does Espresso actually work? How does it run on every single device? Why doesn't it require recompiling, or what's the magic? So we have a tale of two APKs. So when you push the compile button on your project, it builds two APKs, and I've called it main APK and an app test APK. So app test APK contains all of your test logic. Nothing else, well, except for the Espresso runtime, but it has the test logic. And main APK is the same APK that you would release, I don't know, publish to Google Play or something. So then using the magics of, what was the name of the thing? ADB, so Android Debug Bridge. So using the Android Debug Bridge, something invokes the app test APK, which in turn actually starts running your APK and sort of pushing it. So you can imagine this whole process being just like your app is running and it knows nothing that somebody else is touching it, except that somebody else is touching it. And the app test APK is doing the actual testing. So you don't have to mix those two logics together, because there is hardly anything worse in your in your production code than having test code which says, if not in mock tests right now, do one thing, else do another thing. No, never. So that is one of the main points of this talk today. So in the bad old days, and those were not all that long ago, like 3 months ago, you had to go about guessing what would be an appropriate matcher for something that you wanted to find. It is always best to try to think about things, well, what is the most descriptive matcher that is going to match only the thing that I'm looking for? So if there are for example, if there are 10 rows of something on your screen and each row has text field in it saying row, then you don't want to just go ahead and then look for things that match only text. You want to say, if something in row 0 has text of row, then check something on this. And so we would go about this by looking at things and trying to figure out what it was and hoping to God that they would match only that element. And if nothing else works, there's always the layout manager or layout analyzer thingy, where you can go in and look up like what ID this thing has or what text it has and find it. So those days are gone. Android Studio 2.2 has brought us the glory of Espresso Test Recorder. Who has used Espresso Test Recorder? A little bit. Okay, so you can find this functionality under the Run menu. If you have Android Studio 2.2 or higher, it's under the Run menu. So essentially what it does, it runs your application in one window, and then as you press certain things, like for example you press the fab, and it registers that you have just pressed that fab exists. Or the way I went about this was I clicked something with an accessibility description filter. I then pressed back, then I did some searching, then I put in some search text, pressed search, asserted that this button should always be there, which is the actual thing that I wanted to check. Is the fab always visible? and for some reason tap the element at position 0. So what's happening here is that it's actually recording the things that I'm doing on the device, showing to me in human readable form, and once I click save and finish the I'm adding some assertions here, but once that is done, it generates the test code for me, actual Java code, which is mostly nice, mostly with an asterisk, because in a somewhat elaborate setup, you can never generate like the perfect code, but it gives you like a really nice starting point. For example, if some of you are adventurous, I challenge you how to find the perfect matches for the back button. I challenge you all. That's a really nice way to waste like 2 or 3 hours. Okay, but this Espresso test recorder is still in somewhat of a beta. It's not like fully stable, it has some quirks, but the bonus that you may gain is that you can now ask your product people or your QA team or, I don't know, your mom to add some UI tests in your app with just a minor intervention on your part. So that should go well. Okay, so Firebase Test Lab. Who has heard of Firebase Test Lab? Nice. I'm gonna bring something new to this crowd. Firebase is a company that Google acquired, I don't know, a bunch of years ago. And they rebranded a lot of their products. They incorporated them into Firebase, I think like half a year ago. GCM, like Google Cloud Messaging, became Firebase Cloud Messaging. And one of the other things that they kind of sneakily launched into like sort of a private beta, but then silently went public with that, is Firebase Test Lab. So they have huge rooms filled with racks and racks of real actual devices, which Google has either made an agreement with the OEM to install slightly modified versions of Android on it, or they are running just the stock version of Android. So what you can do is upload only those 2 APK files that you generated, upload to Firebase Test Lab, and they are going to run them through every single device and that device configuration that you can have on those devices. And they're going to provide you with the test results, test recordings, and you need to have exactly 0 devices on your table. Who has ever had the problem of having like 5 Android devices on their table and then, you know, cable management going wrong and all that shit? Don't be shy. I hope that's not only my problem. Okay, and it has a continuous integration. Okay, yeah, it has a continuous integration, which is really nice if you are building your apps in APKs in, for example, Jenkins or Bodybuild or I don't know what else brand spanking new system there is, but you can just make that one of the steps, which goes out there. No more emulator provisioning, no more trying to figure out what went wrong, what should be installed on each emulator, and just, you know, testing. So cons of Espresso. Your tests may become flaky if you're not useful. I'll give you an example. So in our app, we try to be somewhat smart in that when the user had first installed the app, and if they registered on this specific device at that time, the first time they logged in, we would open the drawer for them. You know, just to show that, hey, there's a drawer and there's some other options and you can, you know, click stuff here. So if you go into your Espresso tests, well, then the first test is going to have that drawer. If you have, let's say, 10 tests, the first test is going to have that drawer opened because, you know, it's the first install. Well, the second test may not have that open. So if you write your tests to always close the drawer during those tests, like everything after the first test are going to start failing. And you will be tempted to write ifs, saying like, well, if this thing is visible on the screen, and then do this thing, but if it's not, test for something else. And you should never, ever write that in a UI test. If questions, if are extremely bad, you should only write matchers and write assertions to check if those assertions are correct. And Espresso kinda, it allows you to shoot yourself in the foot in this regard. The good thing is that there are a lot of talks out there which explain why these things are bad and how you should be avoiding them. So OS level animations are a pain. Because Espresso kind of knows when the activity lifecycle is going on, but it has some problems. For example, if and I think Samsung devices were the ones who had like really long animations going on between transitions of the screens. So yeah, there are a bunch of code snippets out there that you can do to just disable animations, and you should do them. Everybody says that you should be, and if you don't, your tests are going to become flaky. Espresso tests may take quite a while to run. I think our test suite takes about 5 minutes, and we don't have that many tests. Yeah, and you really have to be careful about managing your test device state. Making sure that if you do some logins or logouts, that you always clean up after yourself after one test is done. So every test can begin from some sane state. So you don't make your tests flaky, because flaky tests are worse than no tests. Don't have them. If you have flaky tests, and if they are sometimes failing, either fix them or disable them. It's just, it's death to your team's morale, and yeah, just don't. Okay, so now to the main meat of this talk. So why would you want pairing Dagger and Espresso? The first Espresso test that you're gonna write, provided that your app doesn't have anything, are going to be something like, for example, registering. So, you know, how do you register? You tap on the form, you input some fake email, you input some fake password or something, you click register, and then you do something in your test. So what is happening, you're actually hitting your real backend or registration server or authentication server or whatever. And that takes time. And that is error prone. So what happens if the API is down for, let's say, 10 minutes? You didn't know about it, and you don't really need to know about it in production. That is down because, you know, it's gonna pick itself up at some point. But now your tests failed. So if your tests fail, you're going in there and you're trying to figure out, like, hey, why did this fail? Why did my test fail? So half an hour later, you found nothing. Your test went perfectly. You do another run on Espresso, and it runs perfectly again. So what do you have? Can anybody tell me? What do you have?
Frustration.
Yes, frustration is a good first step. I was going for flaky, but you know, frustration also does. So you have, again, a flaky test. And what do we want to do with flakiness? We want to avoid it. So by using Dagger, you can inject like mocked backends or mocked web requests or HTTP requests. You don't, because you want to test things repeatably. You're going to want to have some set value. For example, if you're testing, if your device shows the current date, you don't want to get the current date in your test code, like asking like, hey, new date, that current date, blah, or what is the current date, and then asserting that that is the same thing, especially if you're doing like timestamp comparison. But yeah, you want to test things repeatedly. And hitting up real services takes time, and time is something that you don't want to waste. I think if we did everything by the best practices and mocked out every single call to our backend, our testing time would probably drop by about 80%. So just don't. I'm not going to claim that this is my own idea. A A lot of people have written about it. Is anybody subscribed to Android Developers Weekly newsletter? Yeah, we have a couple of people. They just had a story like 2 days ago that was essentially all the code that is in these slides. And I didn't rip them off, I promise. I had the idea for this talk before they went live, but it's not a new idea. Chiki-chan has a really good GitHub repo that demonstrates how you can get the bare bones version up and running. And Fabio Collini, his approach is really nice and takes care of some problems that are in there with singletons that I'm gonna address a bit later. And I'm assuming that these slides are gonna be out there after this talk. So if we have an app that has Espresso in it, and this is my crude attempt to display how dependency injection and testing might work in this setup. So if you have just your main app, there's some sort of process runner which asks like, hey app, give me what is your task runner? It gets handed the default task runner by the operating system. The task runner knows to run your application with the simplest settings possible. It just starts your subclass application file if you have such a thing, and it initializes the dependency injection graph, and then everything onwards from that just asks like, hey, give me all the dependencies that I need. Well, your main activity may be asking like, hey, give me a date formatter, or it may be asking, hey, give me a users database, or give me, I don't know, anything like a preference provider or whatever classes you may have. So the main idea of adding Dagger into this mix is by swapping out this step in the middle. So the way that we do this is, and you'll remember that the tale of the two APKs. There's a main APK who knows nothing about the test APK, and there's the test APK which knows, hey, I need to run the main APK in a certain way. So one thing that we can do is say to the task runner, hey, I have a specific test task runner, and it's gonna use my test application instead of my application from this APK, and it's gonna initialize its own dependency injection graph, where you can then provide, like, for example, mock date formatter, mock database provider, offline or in-memory users database, and then provide that dependency graph to your main APK. So what you've essentially, there is an easier way to accomplish this. You can just tell your application, if is being tested by Espresso, do this initialization, else do the normal one. And this is something that you rarely want to do, because at that point you're mixing the two things together. So your production code knows things about testing. It knows how it's supposed to be tested. And mixing that logic makes it more error prone and less predictable. So there are a bunch of caveats in this. So they have to be running in the same process. And if you have like a really elaborate setup where things are running in different processes or whatnot, this might not work. But for most cases, this is going to work nicely. So yeah, as I mentioned, we create another dependency graph and then pass it to our main application. And now we have ability to mock certain things and provide stubs for other. And things that you can do with this setup is, for example, we have a bunch of event tracking code, and we don't want to initialize it for the Espresso test because it may take a long time and we don't record those events anyway, so why waste the time initializing them? Long running things like doing some weird, I don't know, glyph caching or whatever. We can not hit our real backend, and we can insert appropriate test data before our test starts running. So it's again the same thing about testing dates. You just, you provide a well-known date beforehand, and then test if it's displayed where it should be displayed. And you know, the process is fairly simple, and the next couple of slides are going to have some Android Java code. If somebody has allergic reaction to Java code, please look away now. And these really are 95% of the things that you need, but the 5% remaining are written out in Chuki Chan's article and Fabio's articles as well. So the first thing that we need to do is create a custom test runner. Essentially copy paste from some other project, replacing mock demo application with your own application's name. That's it. Don't need to know anything else about this one. Create a custom test application. My application assumed that you had in your real application, you had a method called create component, which returned the bootstrapped Dagger dependency graph. Override that method to be able to give in your test graph. And I remembered that a really important thing here, what this does, I didn't explain what this actually did, is it tells your application that when it starts running, it should be loading this application class instead of your main application class. That's the main thing. Just swap things out. After that, just hook up your test-only modules by extending them from your application's real modules, and then don't auto start the activity. This is really a key point that Espresso tests are good like that. They come with sane defaults, and the sane default is if you want to test something called main activity, then by default it's going to auto start it. But you need some time. You need to provide some time for your mocked, like the mocked dependency injection graph to be constructed and pass it in your into your application. So that's essentially what's going on here. We're asking the system to give us the thing that is actually being run right now, which and give us the application context. That's where we can get the demo application. Then we can ask, hey, give us the test component, the dependency injection graph. And then we can say, okay, so graph, give me all of the dependencies that I need for this. In this case, I haven't put any here, but it could be anything that you have in your graph. And when you actually run a test, so I have a test with a test annotation as those things go. So you can use Mockito or any other mocking library that you want and say, hey, so when, and clock is something that's injected. So you say clock, when something is asking clock to get now, always return a specific date time. And so what you can do afterwards is launch the activity and check if the specific date field that you are looking for has the exact same value as you provided before. It's that simple. So once you do the initial bootstrapping in those previous slides, you just go on and mock away here. This might be mean, but can somebody spot the main problem here? It might not be only... Sorry?
Services and concurrency.
Services and concurrency, yes. That's one of the things. Anything else? So the main thing here is that doing this mocking call relies on the provider being a singleton. So you can only, usually Dagger works like this. You create a provider where provider returns some sort of object. For example, you're asking it to provide, for example, datetime. If you have a provider method which returns a datetime, every time you would ask it like, hey, give me a datetime, it would do the instantiation all in you, saying like, every time, new datetime. You ask it another time, hey, new datetime. Ask it another time, hey, a new datetime. But there are certain situations where you can ask it, hey, make the provider a singleton, where it's going to create the value only the first time you request it, and then return the exact same value or the object. And this can be useful, for example, if you have, for example, single thread database solution. So it will usually anyways be a singleton, and it makes it easier in that case. But that is one of the harder things that you have to work with non-singleton injections. And the solution to that problem was provided in the second link in the TLDR slides section. You will probably get these slides afterwards. They're going to publish them. Are we going to publish these slides anywhere? Anyone? Huh? No? Please do that. Okay, we're gonna definitely publish them. But they're going to be there's a solution to that problem. But if you have things that are singletons already, you can test them easily. You shouldn't be converting non-singleton things to singletons randomly just for the sake of testing them. That's not a really good idea. Another caveat is that you have to have the same package for the same things. For example, if you have a package my.application.app myapplication.java for your main application class, you should have the same package in your testing hierarchy. This took me a couple of hours to find out, because man, the Chuki-chan's version is, by the way, is fairly bare bones, and it doesn't take into consideration like more hardcore application setups, but it should get you started. So you have to take care of the app state, as I mentioned before, and especially if the things that you are mocking are singletons. Because if you mock something in a singleton, it's going to be there mocked in the same state when the test finishes and the second test starts running. You really have to, you have to wrap your mind around it, that it's going to be there. I think the easiest solution is to just have some sort of reset method, which resets everything to like some sort of sane defaults. But definitely keep that in mind. You always have to take care of setting animation duration. Like I mentioned before, animations are a huge source of flakiness. And there are a bunch of I think it's like 1 or 2 lines of Gradle. It's an activity test rule added into your Espresso base class or whatever, but you have to take care of those animations. And this is something that's coming mostly from me, but in my mind, Espresso tests should be using accessibility features whenever possible. Instead of asking, hey, does this ID contain this specific this value, you should be using, for example, if we use the same analogy as having a field with today's date, you should have a content description for that saying this is the today's date, and then in your tests ask, hey, find me a field whose accessibility content is to date, or use Android resources or strings. All of that can be done inside these. And it's mostly because you really don't want to tie yourselves down to having, like, for example, a specific implementation of a field. If you ask, hey, is field always an edit text? All is well, edit text with a specific ID, all is well and good, until the moment that you change that edit text type to, for example, text view, and your test starts failing because you've sort of made your matcher too specific, and there is such a thing as too specific. But if you instead ask for a content description, well, your accessibility description should always match what's in there. So you're essentially giving people with impaired vision better way to access your app and making your tests less flaky at the same time. So in my mind, that's a really good way to approach this, and you really should be using that. So with that, that's the end of my slides. Do I have any questions?
Yes.
How do you think to develop on mobile, Java is the better opinion, or there is something better to mobile app? Because there is here iOS, there is Android. Like that.
Well, in my mind, Java is almost never the best option, regardless of what you're asking for. Is it mobile? Is it backend? It's rarely. It's a really good choice if you want to get like an MVP off the ground, but it's, you know, on at least on Android you have Kotlin, and Kotlin isn't really mature yet. But man, oh man, once you go Kotlin, you don't want to write Java again. On the backend, things like Clojure and Scala, those are really good things. And then again, you know, mobile or like hybrid apps have been really getting their footing lately. So in the end, I sadly don't have a definitive answer to your question, but I'd say that if you're currently writing your app solely in Java, now would be a good time to jump in the fastly accelerating train of Kotlin. And in my mind, it's going to be like a way nicer experience to maintain your app in the long term.
Kotlin is like framework, yes?
No, Kotlin is a programming language that compiles to Java bytecode. So Kotlin is built by JetBrains. JetBrains is the company that makes IntelliJ, that makes Android Studio. They have a specific division whose sole purpose is making Kotlin. And Kotlin brings a lot of really neat features like immutability by default. It has null safety. Like the way you do switches is so much nicer. And at the same time, it is fully interoperable with Java. So you can use Java classes inside of Kotlin and Kotlin classes inside of Java. So you don't have to sacrifice anything much, except for a little penalty on compilation time. That's still there. But if you just use Kotlin and you get rid of Java entirely, you know, it's not going to be there. By the way, we're writing most of our tests in Kotlin. It may not be ready for production just yet. Maybe in a month or something, but yeah, it's really nice. Okay, anything else? Okay, yeah.
What kind of continuous integration are you using, and are those expression tests around there automatically?
Mm-hmm. We are using Jenkins that is hosted on premises, and the support for we've had a really bad experience in the past with Android emulators running on that Jenkins instance. So the short and painful answer is no, we're not running them. But we have pre-commit commands on our computers which run them before we do a final push. So we run them on our laptops before delivering them, but we've done I've done a bunch of tests with writing this and then running them in Firebase Cloud Lab, and it runs spectacularly. It's like it's such a weird feeling that you can upload just 2 files and like 5 minutes later you've tested your app on like 50 or 100 different configurations. It's oh so sweet. Also costly, but you know, sweet. More questions?
Okay, thank you, Jānis, for an interesting talk.
Yeah.
That's a small present
Cool.
from us.
Yeah, thank you.
Yeah.
Thank you very much.
So now we have